Hello everyone, welcome to Maths Expressions. My name is Alexander Maduka, and in today's video we'll be looking at Seco Theorem 2. In our previous video we discussed Seco Theorem 1, and in today's video we'll be looking at the second Seco Theorem. In case if you are watching our video for the first time, I will advise you to go and watch our previous videos so that you will see how the lecture is being organized, and so that you can also follow along with what we are doing in this channel. And like I said earlier, we'll be looking at the second theorems in today's video. Now let's get started. What does the theorem say? It says that when two triangles are drawn in a circle such that their base lengths meet at the circumference of that circle, they form an angle at that point which is equal to the difference between angle of base length of those triangles if the angles are facing the same direction. This theorem is called Fredonm's theorem. And what does all these statements mean? I will explain everything to you in this diagram. With this simple diagram here, what all this thing is trying to tell us is that when you draw two triangles in a circle, this is a circle. This diagram here is a circle with two triangles inside. The first triangle is this green triangle, while the second triangle is this red triangle, and the base lengths are these blue lines. This first blue line is for the green triangle, while the second blue line is the base length for the red triangle. And this theorem here is trying to tell us that when you draw two triangles in a circle, in such case like this, the difference between angle C and angle A is equals to angle B. That is all about what the theorem is trying to tell us. As you can see here, angle EBF, which is angle B, is equals to angle BCF, minus, which is angle BCF, which is angle C, minus angle BAE, which is angle A. Like as it stated in a simpler equation here, angle B, this angle, is equals to angle C, this angle, minus angle A. Now, how do we get this theorem? How did this theorem came to be, and how true is it? That is what we're going to do in our next step. That's our next step. Our next step is to prove that angle B is equals to angle C minus angle A. Now, if you look at this diagram, this is a simple diagram designed to prove that angle B is equals to angle C minus angle A. And the first thing you see here is angle ABC plus angle BAC is equals to angle BCD. That is, angle J plus angle B is equals to angle Y. Angle J plus angle B is equals to angle Y. Why? Because it's an exterior angle of a triangle. As we all know, this is one of the theorem from our basic geometry. Now let's call this equation 1. Now the next thing here is angle ACB plus angle BCD is equals to 180 degree. Why? Because they are angles on opposite segment, and they are supplementary. Angles on opposite segment are supplementary, as we also know from our basic geometry. Angle C plus angle X is equals to 180 degree. Angle C, this angle here, plus angle X is equals to 180 degree. Angles on opposite segments are supplementary. Let's call angle C plus angle X equals to 180 degree equation 2. Now let's go to the next thing. The next step here is angle ACB plus angle BCD is equals to 180 degree. Why? It is because angle on a straight line, angle X plus angle Y is equals to 180 degree. Angle ACD, all the angle on this straight line here, which is angle X plus angle Y, these two angles, all of them lies on this straight line. and they are equals to 180 degree, as we also know from our basic geometry. Let's call this equation equation 3. Now, from equation 2, this equation here, angle C is equals to 180 minus x. And from equation 3, angle x is equals to 180 minus y. If you rearrange this equation, it's going to look like this. Now, substitute 180 minus y for x in equation 2 in this equation which we derive after rearranging it. If you do that, your equation will look like this. Angle C is equals to 180 degree minus, open bracket, 180 degree minus y, close bracket. If you open the bracket, it will be equals to 180 minus 180 plus y. And at the end, 180 minus 180 is equals to 0. At the end, we finally have C is equals to y. Then the next step here, from equation 1, this equation here, from equation 1, y is equals to j plus b. If we rearrange, okay, as you can see here, y is equals to j plus b. Therefore, c is equals to j plus b. Since c is equals to y, c is also equals to j plus b. Then angle ABC, sorry, plus angle ALC. Okay, angle ABC is equals to angle ALC. That is, angle A is equals to angle J. Why? Is because it's an angle on the same segment. Angle on the same segment are equal. Let's go back to our diagram and confirm that. If you look at our diagram, it says angle A is equals to angle J because the angle on the same segment. Look at how the angle looks like. As you can see, is the same segment, is inside this segment. And if you look at angle J from here to here, these two angles are in the same segment, which is this segment here. These two angles are connected to this chord here, which is called AC. This line AC, these two angles are connected to it, and they are equal, as we know from our basic geometry. Now let's go back to what we're doing. It says angle A is equals to angle J. Thus angle A plus angle B is equals to C. Angle A plus angle B is equals to C. As we know that A is equals to J and C is equals to J plus B. Therefore, A plus B is equals to C. If you rearrange the equation, you will get our theorem, which says B is equals to C minus A, and that is Fredonm's theorem. As you can see, we finally proved that angle B is equals to angle C minus angle A. Now let's look at the worked example. Let's look at this simple example. The question says, find the value of angle EBF in the diagram below. Angle EBF, this angle here, which is angle B. Now let's look at the simple solution. Solution. Now let angle BAE, which is angle A, angle BAE, which is angle A, is equals to A. Let's call it A, and which is equals to 35 degree. Now the second one, angle EBF, let's call it B, which is equals to unknown. That is the angle we are given to find. Now angle BCF is equals to, let's call it C, which is equals to 63 degree. Now from our theorem, it says angle B is equals to angle C minus angle A. That is Fredonm's theorem. Then from this equation here, now we can say B is equals to 63 minus 35, which is at the end we get B is equals to 28 degree. Therefore, the value of B is equals to 23 degree. That is angle EBF, that is the angle here, is equals to 28 degree. Now let's look at the next example. This one is an exercise. I will leave this one for you to do it, to know if you understand what this video is talking about. And I will leave this exercise for you to do it and drop your answer in the comment section. It says if angle JKN is equals to 25 degree and angle JMK is equals to 60 degree, what is the value of angle KNL? That is the exercise for you to do to know if you understand what this video is talking about. As you can see, the diagram is already drawn with the letters labeled at each point to show where these angles are located. It is left for you to find where the angles are located and do the equation and tell us your answer in the comment section. Find the value of angle KNL. And that is it for this video. In this video, we have shown you what Fredoms theorem is all about. We also try and prove how the freedom came about, like how the theorem was driven. We prove how the theorem came to be, and we also did example to see how the theorem is working, and we finally found out that the theorem is true. As you can see in this video, we have tried and pull and show everything to you in detail. Now it is left for you to do this simple exercise and tell us your answer in the comment section to know if you understand what this video is talking about. And that is it for this video. If you find this video helpful, like this video and share this video so that it will get to another person that might need this video, because this is a very interesting topic which everyone who loves mathematics will like to know. And I would also like to know what you think in the comment section. If you have come across this theorem before, also let me know in the comment section. And if this is your first time of seeing this theorem, also let me know in the comment section. Like as I said, the video or some of our topics we'll be discussing here in this channel might be very new. Yes, it might be very new. It might be the first time of that theorem or topic being discussed on, or of you meeting those videos in YouTube here or whatever in the internet. Yeah, I promise you. And in our next video, we'll be discussing more and more. In our next videos, we'll be discussing more and more interesting both related topic and some very new topics in our next videos. So don't forget to subscribe to our channel so that you will get notification whenever we upload our new videos. And thank you very much for watching this video. I would like to see you in my next video. Bye.